Hi, so these are notes on sedimentary rocks, and sedimentary rocks are formed when sediments, pieces of little rock, are weathered and eroded from other rocks. Could be igneous, metamorphic, sedimentary rocks that break up. They get carried away by streams or rivers or glaciers or wind. They get deposited, buried, compacted together, and then they get cemented together. And if you look on page 6 of your reference table, this chart right here is on there. And it shows that in order to get a sedimentary rock, you have to have any of these metamorphic, sedimentary, or igneous. They have to be weathered and eroded. They turn into sediments. You get deposition, burial, compaction, and cementing. This is, if you forget how sedimentary rocks are formed, it's right on the reference table. It's right there. So that's where sedimentary rocks come from. Now, we classify them in 3 different ways. And they're classified on the next page in the reference table, page 7. You'll see clastic, crystalline, or bioclastic. So this chart sort of breaks it down. And so you have the rock names over here. These are the different types of rocks, some comments on them, what they're made out of, and the size of the parts that make them up. And let me just explain what this clastic means. Clastic is just a clast is just a piece of sediment. And those clasts, all those little clasts, are then glued together, stuck together in what's called a matrix. So the stuff that glues them together is called the matrix that holds them all together. And the pieces that make them up is what really sort of defines sedimentary rocks. Sedimentary rocks are made up of pieces of rocks or fragments that are stuck together. Those are those clastic rocks. So clastic rocks, we classify them by the size of the grain size. They're formed when rocks are broken up, deposited, buried under lots of other rock or sediments, lots of other sediments, and then compacted and cemented together. The examples that we have are directly from the reference table: siltstone, sandstone, conglomerate, breccia, and if we look, I'll go back to that, but if you look, water, if you have a stream of water flowing into an ocean, and we've talked about how streams can pick up and carry sediments, and then when they get into the stream, or they get into the ocean, they then drop that material. And year in and year out, you get lots of deposition. Those layers of sediments pile up. The sediments get buried in there, compressed down by the other sediments that are above them, and as the water is sort of squeezed out or sort of evaporates out or moves out of the solution, you'll get the minerals that are left that actually act like that matrix to hold them together. So you get these layers upon layers of sedimentary rock formed over millions of years. And you can see there's a couple examples here of what's called conglomerate, which is all different size particles, sometimes very large particles, cemented with other smaller particles. You might get a sandstone where you get sand-sized grains cemented together. So that's where these clastic rocks come from. Clastic means fragments. Those fragments of either pebbles, in this case for conglomerate or breccia, boulders, clay, silt, sand, all mixed together, create either conglomerate or breccia. The difference is that one's rounded, has rounded particles, the other one has angular particles. So if we look at the conglomerate here, you can see these particles are nice and rounded. Breccia would be different sized particles, but they would be angular, or they'd have sharp edges to them. The sand, you can see the size of the particles determines which type of rock it is. So sand is between 0.006 and 0.2 centimeters. We consider that fine to coarse, and that would be sandstone. These symbols over here on the other side are not necessarily what the rock looks like. It's what the symbol is when we start looking at rock layers on diagrams in questions and on maps. They use these symbols to help distinguish the different kinds of layers of rock. So that's what these are for. These are not what the rocks look like in real life. This is just a symbol that we use for maps when we're looking at geology. So that's the clastic rocks, the fragments that are cemented together in some sort of a matrix. Usually it's a quartz that minerals that sort of hold those together. Sometimes it's calcite that holds it together. The crystalline rocks are classified. We divide them up by what they're made out of, their composition. They form when crystals precipitate out of water or evaporate, precipitates or evaporates, and I'll talk about that, what that means in a second. But rock salt, rock gypsum, dolostone, those are all examples of these sort of crystalline types of rocks. And if we go back to this diagram, what ends up happening eventually over time is that oceans can dry up. We can have changes in the climate and the water starts to evaporate away. And once that water evaporates, we've talked about this, the salt that's left behind, or the lime, the calcite that's left behind, or whatever mineral it is that's in the water, has no place to go. It settles out. It is what's called precipitating out. It sort of rains down out of the water, or as the water's evaporating, you'll get these evaporates, which are the similar process, where you have the minerals then are sort of settling on the bottom of the ocean or the sea, and as that water evaporates, more and more of it piles up, and eventually you'll get crystals of salt formed. And you'll get little bits of rock embedded in it as well, because it's not just pure, it takes a long time, and you'll get sediments that are washed into the water as well. So this rock salt tends to be kind of dirty because of that. But you'll get these crystals of these minerals, and they're formed, as precipitates and evaporates. So as water evaporates, that's where these rock salt, rock gypsum, and dolostone come from. They're made out of halite for rock salt, gypsum, rock gypsum, and dolomite for dolostone. These were all minerals that we saw in the reference table on the last page. They're made out of crystals. That's why they're called crystalline. Okay. The last classification that we use is called bioclastic. And if you think of bio, think about where you've heard that before in science. Bio meaning life, right? And clastic, we just talked about clastic being fragments. So this is rocks made out of fragments of life. So what they're composed of sort of defines which type of rock it is. And it's often cemented shell fragments or other biological origin. So sometimes plants can be compressed together. That gives us coal. You can also get other calcite that is produced by shells and other marine organisms that will help to create those. So we get limestone as an example. We also get plant remains, and the examples of those would be coal. Oh, sorry about that. Would be coal. Is our example. So when we look down here at these bioclastics, you can see that crystalline or bioclastic, it could be either. Limestone can be created either way. And remember, it's calcite, so it's going to, if you think about what the special test is for calcite, think about that. If you can't remember, look to the last page of your reference table. How do we determine if it's calcite? That's one way we can determine whether a rock is limestone or not. Bioclastics, bituminous coal that is made from plants. Millions of years ago, the amount of carbon dioxide in the atmosphere was a lot higher. There was a lot more plant growth. Those plants died without being decomposed. They get pressed together, and over time, that pressure creates presses the plant material together enough that you get coal. And then we take that, we burn it for energy, and produces carbon dioxide again. the the interesting thing about sedimentary rocks is that they are formed in horizontal layers. So if we don't see them in horizontal layers, if we see sedimentary rocks that are tilted off of that horizontal layers, then we know some sort of plate motion has caused those layers to get tilted or lifted. You'll sometimes see layers in rocks that are all distorted or in curvy bands. That's not a sedimentary rock then. If the layers are distorted or bent, then it's no longer going to be sedimentary. Sedimentary rocks are really just horizontal layers or layers that are parallel to one another that may be tilted at an angle one way or another based on how the plates have collided. They happen at the Earth's surface because that's where all these processes of weathering, erosion, biological activity, deposition, all those things happen at the surface, and that's why we see a lot of the rocks that we see are at the surface are sedimentary, because that's where these rocks are created. Mostly, if you find a fossil in a rock, you can almost guarantee that it's a sedimentary rock, because the other types of processes destroy the remains of those organisms. So igneous rocks melt them. Metamorphic rocks deform them or press them, because metamorphic rocks are formed from pressure, pushing the rocks together to change them. So most of the rocks that have sedimentary or that have fossils in them, all of the ones that we're going to worry about, are exclusively sedimentary rocks. You can't get fossils found in other types of rocks for our purposes. So that's the sort of basis for sedimentary rocks. We'll spend some more time looking at them in terms of the rock cycle, but that's a good start for you.